In this problem, we're given that two matrices, which we call capital A and capital B, have particular orders. That's rows by columns. And the A matrix is a 3 by 1. The B matrix is a 1 by 2. So that's A has 3 rows in one column, while B has 1 row by 2 columns. And we're asked to find the following orders of the products of these matrices if they exist. So if they don't exist, don't bother to answer the question about what the order of the answer will be. So let's get started on the first product, A, matrix A times matrix B. Okay, solution, matrix A is a 3 by 1 order times matrix B is a 1 by 2. Let's check to see if the inner entries match. Yes, the inner entries are 1 on the left and 1 on the right. If they match, that means if they're equal, we are allowed to multiply these matrices. So the product A times B does indeed exist. Now we're going to find out what the order of the product is by writing the outer entries 3 by 2. That is the order or the size of our product. So A times B exists because the inner entries are equal, and the order of A times B is going to be a 3 by 2 matrix, 3 rows by 2 columns. Now let's see if we get the same answer for B times A. We're just swapping the position of the matrices. So the first matrix B has an order of 1 row by 3 columns, and then times 3 rows by 1 column for matrix A. Compare the inner entries. Oh, wait a minute. 2 and 3, they're not equal. And since they're not equal, we cannot even do the multiplication, which means the product doesn't even exist. When something doesn't exist, we say DNE, does not exist. So we can stop right there. We don't need to go any further. When we see the inner entries are not the same, we stop and say the product B times A does not exist. We can leave the problem and we're finished.